Hello everyone and welcome back to DTS Programming. My name is Daniel and today I'll be discussing my Project 3 enemies for my Programming for Game Engines course GPE340 at the University of Advancing Technology. So for this stretch of the project we had to implement enemies that could navigate around the scene using group motion. Designers should be able to change the movement speed. The enemy should also use weapons as well as chase and shoot the player. Enemies should spawn into the scene over time and ragdoll when killed, and then a special mechanic should be included that relates to the enemies or navigation. So getting started, we'll first take a look at the enemy character that I brought into my game. This is the enemy cyborg I got off the Unity Asset Store. As you can see here, the sci-fi cyborg from Sergio CG. Of course, I also still have my player character, as well as all my previous animations and any additional animations that I brought into the game at this point. So jumping into my game, you see my player can still move around with camera tracking. I have enemies chasing and shooting at my player. I have my health UI percentage and health bar. Each of my enemies also have health bars. You can see that I'm taking damage and that I can also die with ragdoll death and respawn at start. So moving on to a view of my scene, as one of the core mechanics we use nav mesh to control the enemy AI. You can see here that I have my nav mesh baked in. I have my agent radius and height set to 0.5 and 1.8. I have a max slope set to 60 degrees. As you can see here, these slopes are too steep for the agent to climb. Step height of 0.75, drop height of 5, jump distance of 2. And so this is how my enemy AI are going to track after the player. So let's go ahead and take a look at the code at how the enemy uses the nav mesh to navigate around and target the player. So here you can see I have a weapon field to find which weapon my enemy is holding. I've added attack detection values here with attack range and the attack rate with some booleans to verify if the player's in attack range has already been attacked, and then a variable to store my player. I have some layer masks. This helps with my detection code later on. Ground mask and a player mask. Transform for my player target. Vector 3 for my desired velocity, which is going to control my AI movement. Of course, my enemy nav mesh, which is a required component of this class. I did a requirement for the nav mesh agent as well as the animator, as my enemy AI are going to use root motion in conjunction with the nav mesh. And here I've defined some public events which will tell my weapons when my enemy has attacked. In my awake function, I define my enemy nav mesh as well as my enemy weapon. I call to my base awake, which is in my pawn class. Here in my pawn class, I have my health and my animators, getter and setters. In awake, I just get the pawn components, which is getting those values for the health and the animator. And then I set rigid body state and collider state. And what these functions will do is basically toggle from the ragdoll setting to the animator setting. So this will initialize my pawns to be affected by physics as the game starts. Taking a look inside of set rigid body state, passing in the state true here. We're going to grab all our children rigid bodies of our pawn class, and for each rigid body in that array, we're going to set their kinematic state to true. Then we're going to get the primary rigid body and set that kinematic state to false, or not the state passed in. The set collider state works in a very similar manner. We're passing in false here for the state. Again, a collider array is created and set to all the children collider components. Then for each collider in that array, collider enabled is false. And then we get the primary collider and set it to not false. Then returning to our enemy code, you'll see on this line we just added a listener for our on-death event, and that is called from the health class. And that will invoke our ragdoll for our enemy. And a quick look in health. Here we have our take damage function. We're checking our health values, grabbing our percentages for our UI. If the current health is less than or equal to 0, we'll first set all the values to 0, pass it to my health percent to display it on the UI, and then we call our dead pawn function. For dead pawn, the first thing we're going to do is invoke the on-death event. Then we're going to check if the game object that has died is the player. We'll call setActiveFalse on the player, and we'll invoke our respawn player function after our respawn time has transpired. Otherwise, an enemy pawn has died. First, we disable the collider on the enemy pawn, and then we'll destroy our game object after 3 seconds. For respawn player, we're just setting the game object back to active. We're returning the health values to full health and passing it to the health percent to display on the UI. So continuing down the enemy class, here we're going to set our player target transform to our player's transformer. Here we're going to set the actual player. In update, we're just calling pawn movement, and then we're going to check for the player range. So first in pawn movement, We're setting our desired velocity equal to vector 3 move towards, which is moving from our desired velocity towards the enemy nav mesh desired velocity over our enemy nav mesh acceleration, and that's times time dot delta time. Here we declare vector 3 input. We set that equal to a transform dot inverse transform direction, which transforms a world space into local space, and then we pass in our desired velocity here. Together these act as input for our AI, and then we will set our animator values, set float horizontal with our input X, and set float vertical with our input Z, and then our animator damp time over time.delta time. We also have our onAnimatorMove function, and all this is doing is setting our enemy nav mesh velocity equal to our animator velocity so that our root motion is controlling the movement and the nav mesh is not causing our enemy to fly around the screen. And check for player range, we're just checking if the player is in range of our check sphere, setting that boolean to true. Then we check to see if the player is not in the attack range. Then we call chase target and pass in the player target. And if the player is in attack range, we call attack player and pass in the actual player. Chase target is very simple. Again, we're passing in the transform of the target. If the target does not equal null, then we call the enemy nav mesh set destination function and pass in the target position. So nav mesh makes that process really easy and will take care of the rest of the work. If our enemy is attacking, we have our enemy nav mesh set destination to the enemy's current position, which will cause the enemy to stop in place. Then we take the transform and call the look at function, pass in the target's transform. This causes the enemy to look at the target. If the enemy weapon does not equal null and the player is in attack range, then we'll check if the enemy has a weapon and the player is in attack range. We'll check our already attacked boolean to see if it's false. And if our enemy is holding a rifle, we will invoke the rifle attack event. Otherwise, we'll invoke the handgun attack event and set the already attacked value to true. Then we'll invoke an attack reset and pass in the designer defined attack rate. Otherwise, if the player is not in attack range or we do not have a weapon, we will just chase the target. And for the attack reset, the already attacked boolean is just set back to false, and this gives an attack delay. So taking a look at invoke ragdoll, and again this is kicked off by our on death event from our health class. We will get our animator component and we will disable it. Then we will call our set rigid body state false. This is going to set all our child rigid bodies to no longer be kinematic. And then we'll take our set collider state and set that to true, which will set all the child colliders to true. And again, this will set true the primary rigid body, and this will set false the primary collider. And we can take a closer look at that when I go back into Unity to see what that all means. For our onAnimator IK, this is just for inverse kinematics for our enemy, same as our player. And I have an onDraw gizmo selected. This is simply for visualizing the check sphere to see if the player's in range. Going back into Unity, we'll take a look at our enemy prefab once again. You can see over here we have the enemy script, have a required health. We have an inventory script. This just holds the weapons that the enemy can hold. We have our animator with our sci-fi humanoid controller. This is the same animation that the player uses, as well as the same inverse kinematics that the player uses. Of course, we have our primary rigid body, our primary collider, and our nav mesh agent. Here you see we can set the speed of our agent, of course our acceleration, our stopping distance so that the agent's not on top of our player. In our enemy script, we have our place for our weapon. Our attack range is set to 10. You can see our sphere here, highlighted in red. I have an attack rate of 1, which means you'll pull the trigger every second. Ground mask has been defined, and player mask has been defined as well. Here are my events, my rifle attack and my handgun attack. I just passed in my rifle, which gave me my attack start and my rifle class. And the same with handgun, it gives me my attack start with my handgun class. Quick look at my weapon classes. I have a listener for my player when he is using the rifle to attack, and I also have a listener for my enemy when he uses a rifle attack. Both just call attack start, which starts the coroutine to fire the rifle. My handgun class is set up in very much the same way, with listeners for my player to use the handgun or my enemy. Again, they call to attack start, which just fires the handgun, and that is just a single shot per fire. Again, that's every 1 second for my enemy, so every second my enemy will either shoot 1 bullet or the 3-round burst that I have defined on my rifle. Now let's take a look at how my enemy and my player are set up for ragdolling. We're now in the physics debugger and you can see all my colliders. If we go to my player here, we're going to disable the main capsule collider, which is what my ragdoll function will do on the player's death. And here you'll see it will set all these child rigid bodies to active. It will disable my animator, and it will set all my child rigid body components to no longer be kinematic. Here in my player hierarchy, you can see that some of my parts have capsule colliders and rigid bodies, which are activated or deactivated depending on whether I'm in animated mode or in ragdoll mode. So essentially, when you turn on all these child colliders and disable is kinematic on the rigid body, it basically just causes the character to crumple to the floor. Otherwise, all rigid bodies will be kinematic, so they won't be affected by gravity, and he will be under the control of the animator. Now that we've seen how the enemies can navigate around the map, how they can track the player using nav mesh and the animator, how they target the player and auto attack, we'll now take a look at my spawning system. So here in my scene view, you can see these three rectangles. They kind of look like portals, which is what I was going for. I've placed weapons in front of all three of them, so when the enemy comes out, they'll automatically grab a weapon and come after my player and start shooting. I set this one up on a hill. The reason for that is so I can show my off-mesh link from here to here. I have my drop height, my jump distance as mentioned earlier, but when an enemy spawns in this portal, he will be able to jump down from any of these points, but he will not be able to go back up. And I wanted to implement that as one of my extra mechanics. So we'll be able to see the enemy jump from this upper level to this lower level. So I'll go ahead and start the game, and you can see that my enemies have spawned. There are three of them. They're chasing after my player. In my spawner, you can see that I have 3 spawn points set in an array. My enemies will randomly spawn from a random point in that array. I have my max number of spawns set to 3 as you saw, and my current number of spawns is indeed at 3 with a spawn delay of 0.5 seconds. Quick look at my enemy spawner code. So here I have an array of enemy prefabs, which means that I can put any number of enemies and it will randomly go through this array and spawn one of those prefabs. I only have the one prefab set for right now. Again, my spawn point array, which I'll show in my code, a random enemy will spawn from a random spawn point. And then my spawn parameters, max number of spawns, current number of spawns, and my delay. Here I store my health component to get the health from my enemy clones. Then I have integers to store values for my random spawn prefab and my random spawn point. In my awake, I just invoke repeating of my spawn enemy function. That's going to happen right away, and then it's going to repeat within the spawn delay interval. My spawn enemy is going to check if the current number of spawns is greater or equal to the max number. If that is the case, it will cancel the invoke spawn enemy. Otherwise, if that number is less than the max count, then my random spawn integer is set to a random number in the range between 0 and my enemy prefab's length. Again, a random number is set between 0 and my spawn point's length. And if my current number of spawns is less than my max number of spawns, then I'm going to randomize spawning and pass in those two random integers for my spawn prefab and my spawn point. And here I'm adding a on-death listener from my enemy health, and this will reduce the enemy count when they die. In randomized spawning, I'm just instantiating my enemy clone, getting their health value, and increasing the current number of spawns by 1. And then on the death of an enemy, the clone count gets reduced by 1, and I call awake to restart invoke repeating. Here you can see the enemy taking advantage of the off-mesh link, jumping down from that upper level. So giving it a final look, my player has all the components from my previous assignment. Here I can pick up a weapon, inverse kinematics controlling my player and my enemies. You see that they've picked up a weapon. He's got a rifle, it's doing the triple fire. Health meter is dropping, UI is working, enemy health is dropping, ragdoll on death. When one dies, another respawns. Player health drops to 0, respawn at start. I just stuck with respawning with weapons, with the mindset that I'm not losing inventory when I die. Enemies are basically just firing in my general direction when they do the look at with auto fire engaged. And you can see the guy with the handgun doing single shots. Handgun, single shot, different kind of bullet. I haven't set a life count, but I should probably do that next. Finally, a quick look at our enemy inverse kinematics. You can see that is working. And with the rifle as well. So there you have it. My player can move around, the camera follows and tracks. I can pick up weapons, my enemies can pick up weapons. They will track the player, they will shoot at the player with different weapon types. The weapon script is the same for the enemies and the player. Player and enemies can lose health. I've added in health bars as an additional feature. All pawns will ragdoll on death. My spawners work and will spawn random enemies at random spawn points as defined by designers for the spawn count and the max number of spawns. The enemies navigate through the use of nav mesh. They can also utilize an off mesh link to get from one platform to another. And you can see that my code is still all commented and utilizes encapsulation. You see most of my variables are private except for my public events and a few other things, all private. My weapon class, attack start, attack end, same code used by both the enemy and the player. I've drawn gizmos for my spawners as well as for my enemy check sphere, and all pawns are utilizing root motion and animation. So that will wrap it up for my Project 3 enemies for my GPE340 class, Programming for Game Engines at the University of Advancing Technology.